I'm now moving on to example number 4, problem 1, and in this problem I need to find the equation of the tangent line to this particular curve at the point 1, 3. So anytime I have the equation of the tangent line, I will start off by writing out the actual equation, which is y minus y1 equals to m times x minus x1. And my particular point here is 1, 3, so that's x and that's y. After that, I usually like to just update my equation of the tangent line by plugging in the x and y values. So this will be y minus 3 equals to m times x minus 1. Alright, so that's my tangent line there, and I need to go find the value of m here, and I need to do that by taking the derivative. Alright, so let's go ahead and take the derivative of this expression right here. So the derivative of x squared is going to be 2x plus the derivative of y squared will be 2y times y prime equals to, well, the derivative of x here is just 1 plus, now I need to use a product rule on this last step here. So the product rule states that you need to take the derivative of the first variable or first term, which is 3x squared, and the derivative of 3x squared is going to be 6x times y, and then the product rule states that you need to add the first term, which is 3x squared, times the derivative of the second term, and the derivative of the second term is going to be y prime. Okay, so once we've done that, I will now go ahead and substitute the values of x and the values of y into my equation here so that I can find y prime. So if I do that, my next line would be 2 times, well, x is going to have a value of 1, plus 2 times y, and y will have a value of 3. And that will be y prime equals to 1 plus 6 times, well, x has a value of 1 and y has a value of 3, and then plus 3 times x squared, well, x squared is just going to be 1 squared times y prime. Okay, let's go ahead and now evaluate these numbers and isolate for y prime. 2 times 1 is 2 plus 2 times 3 is 6, so that would be 6y prime equals to 1 plus 6 times 1 times 3 will be 18 plus, and 3 times 1 squared is going to be 3y prime. Okay, let's continue here. If I add the 1 and the 18, I will have a 19 there, and then this 2, I'm going to move that to the other side, so that's going to be 19 minus 2, and then this 6y prime I'm going to move to the side here, so 6y prime, and then I'm going to move the 3y prime to the other side, and that would become negative 3y prime. So you can do all those steps, usually you can do those steps in one shot, and then go ahead and now simplify the problem here. So 6y prime minus 3y prime will be 3y prime, and 19 minus 2 is going to be 17. Divide both sides of the equation by 3, and y prime would equal to 17 over 3. Alright, now to write my final answer here, I would go back to my equation here, and my final answer is y minus 3 equals to 17 over 3 times x minus 1. So that right there is my final answer. Okay, let's move on to the final question in this video. So the last question in your homework is another a question where you need to find, well, it's actually a different question, find the points on the curve at which the tangent line is vertical. Okay, so if a tangent line is vertical, I mean, that means that the slope is undefined. Alright, so eventually I need to take my derivative, and I need to think about a situation where my derivative is undefined. Okay, so let's go ahead and take the derivative here of this particular question, and let's figure out how we can find the points where the function has a vertical tangent line. All right, so part one, I'm going to highlight this part here in yellow. I need to use the product rule. So the product rule states that you take the derivative of the first term, which is x squared. So the derivative of x squared is 2x. And then you multiply it with the second term, which is y. And then you need to add the first term times the derivative of the second term. And the derivative of y is going to be y prime. All right, now I see a minus sign here, so there's a minus sign, and anytime I have a minus sign, I will put an open bracket so that my next product rule, which is in blue here, that's not affected by the minus sign. So the derivative of x is 1, and then I would times that by the second term, which is y cubed, plus the first term, which is x, times the derivative of the second term. The second term is y cubed, so the derivative of that is 3y squared times y prime, close the bracket, and then the derivative of 6 is going to be 0. Okay, so my next step is let's go ahead and distribute this minus sign into the brackets, and let's just clean up this line here. So this is going to be 2xy plus x squared y prime minus y cubed minus x times 3y squared y prime equals to 0. Okay, my next step is I want to get these terms here in yellow on the same side of the equation, because then I can factor out the y prime. So in this video, what I'm going to do is I'm going to highlight the other terms, and I'm going to move these green terms to the other side of the equation. So that means x squared y prime remains minus x times, actually hold on, I think this expression right here I'm going to rewrite so it's not confusing here. I'm going to put the 3 in the front, so it's going to be 3 times x y squared times y prime equals to, now if I move these green expressions to the other side, this one would become positive y cubed, and this 2xy, if I move that over, that would be negative 2xy. Okay. Now that I've done that, I forgot the y prime here. There's a y prime right there. So I will now highlight that y prime and that y prime, and let's factor that out. So that's going to be y prime bracket x squared minus 3x y squared, close the bracket, equals to y cubed minus 2xy. And then I will divide both sides of the equation by x squared minus 3xy squared. Divide that by x squared minus 3xy squared. Those will cancel off, and just to kind of save myself a little bit of time, this is what y prime equals to. Alright, now this is my derivative expression, right? So I want to make my derivative be undefined, because at the beginning of the problem, we're looking for a situation where the tangent line is vertical, and the only way you have a vertical tangent line is when your slope is undefined. Okay, so the good news is this is a fraction. Let me just erase this. And if I want to make this equal to a undefined situation, a fraction is undefined when the denominator is equal to 0, right? All right, so we need to take my denominator here, and we need to set that equal to 0. All right, so that's kind of a new thing now. I don't think we've done too many of these kind of problems. So I take my denominator here, and I set that equal to 0, because that would make my denominator be 0, and that would make my derivative, which is my slope, be undefined. All right, so let's go ahead and isolate for, actually no, we can just go ahead and factor out the x here. So let's factor out the x. So I would get x minus 3y squared equals to 0. Now, if I go ahead and analyze this, there's an x term here and an x term there. So this equation right here in green, I can just set that equal to 0. And then I can make this equation over here, I'm going to set that guy equal to 0. And let's take a look at both cases individually. Okay, so I guess this gives me one of the x values right away. And over here, this is not much we can do here. I can bring the 3y squared to the other side. And these are two expressions that I can use to further analyze the problem here. Okay, so I'm going to go back to the original problem, erase a bunch of things, and see how I can use these two particular statements to to finish off the problem. Okay, so I need to go back to the beginning here, and yes, I will now have to erase all this, and that will just take me a little bit of time here. So I do apologize for the delay, but I need a fresh new screen here to finish off the problem here. Okay, so we last finished off by saying that x was equal to 0 and x would equal to 3y squared. Okay, I'm going to box these two guys, and we're going to figure out what these two expressions mean with respects to the original equation. Okay, so if I have x equals to 0, I can let all my x's in my original equation equal to 0. So if I do that, this would now give me a situation where I have 0 squared times y minus 0 times y cubed equals to 6. And that doesn't really help me because this is 0 minus 0 equals to 6. So I mean, obviously 0 does not equal to 6. So what that really means is x equals to 0 gives us no solutions here. Okay, so since we don't have any solutions there, we need to go ahead and work with the other expression, which is now x equals to 3y squared. Okay, so now I'm going to get rid of the x equals to 0. So now I'm going to take this idea here and plug this back into my original equation here. So let me write out my original equation one more time so that I have a little more space to work with here. So anytime I see an x now, those x's are going to be replaced with this expression right here in green. And that will create a little bit more work. So this is now going to be 3y squared. And since there's a power of 2 here, I need a 2 there. And then this y will tag along minus x, which is 3y squared close the bracket. And then I have this y cubed term here. So let's put the y cubed at the very end equals to 6. Okay, let's go ahead and simplify this. 2 times 2 is 4, and then this y would give me an additional 1. So that would be 3y to the power of 5 minus 2 plus 3 would be 5, so this would be 3. Oh, sorry, I made some mistakes. Let me go back. Sorry, let me go back to this line here again. I totally botched this one. So this 2 distributes onto that 3 and that 2. So this would be 9y to the power of 4. And then I have the y tagging along minus over here on the next line, yes, I can just multiply these two guys, and if I multiply those two guys, I add the powers, so this would be 3y to the power of 5 equals to 6. Just erase all this here. And then this part right here, since the bases are the same, there's an invisible 1 here, so this will now become 9y to the power of 5 minus 3y to the 5 equals to 6. And now I have some like terms here, so now I can just go ahead and simplify here. 9 minus 3 is going to be 6. Y to the power of 5 equals to 6. Then I can cancel off the 6's there. Y to the power of 5 equals to 1. And if I take the fifth root here, the fifth root of 1 is just going to be 1. 1 times 1 times 1 times 1 times 1 is 1. Okay, so that means my y value equals to 1. Now, how do I go ahead and find my x value? Well, the fastest way is you take your y value and go back to this box here, and we can find x very quickly by letting y equal to 1, which is what we found. So now x equals to 3. So our point where the function has a vertical tangent line is the point 3, 1. So quite a bit of work, but that's a very good thinking question with lots of good algebra in there as well. Be careful with this step right here in blue. I initially made a mistake and I had to go back and correct myself. So just remember that this 3 is being raised to the power 2, right? So 3 to the power 2 is going to be 9. All right, so that concludes this video, and we'll see you next time.